Okay. I record this video is for talking about how to improve the PHP malware detection result. So from the existing position the job I have finished is it's a shell breaker, right? So for the shell breaker, we only find the 400 real world malicious web shell, and with the same member of the benign script. So I grabbed 8 language-based feature and has a detection rate like that, and has a false positive rate at only 1%. And you asked me how to improve this result, right? Specifically about the false positive. And I think the one thing is from the ground truth, right? How many malicious web shell or what malicious scripts we can get. So in my paper, we only have a 400, but how about 4,000, right? So if we have enough the malicious sample, and we can enlarge the language feature, right? Such as for maybe for the real time, then we don't need to set some of the 8 feature. Maybe we have 80 features or 100 features that we can grab from uh, the malicious web shell, malicious script, right? I think this it can prove why. In our paper, we have demonstrated that. So at the beginning, as a result, the detection rate only 85%, but we only have the six features, right? Six synthetic features, and we get a 85% detection rate. But when we add another 2 features into the vector, which is feature vector, and we improve the detection rate from 85% to 91%. And that results for here is enough for a published paper, right? But it's for a real world industry solution. Maybe we can enlarge the feature vector, right? For if we can improve the detection rate, I can I think we also can improve the positive rate, false positive rate for the detection result, right? Yep, I think that's one direction. Another direction is about the similarity for the API dependency, right? It's depend on the U checker. My first the system that published in my first paper, and like you said, you mentioned the InfluxDB, right? But I think right now we need to use a graph database, like Neo4j. Oh, sorry, Neo4j, right? It's a Neo4j, and so for after our last conversation, I improved my system UChecker because original UChecker suffers from the path explosion, and I improve it using OR, right? Using all the branch split by the symbolic execution, and after that I will use OR operation to combine and merge all the paths from generated from the UChecker, right? And I use graph database Neo4j, and in this I use some time during from our last conversation, right? I code a small demo by the Python right here using the Neo4j library in the basics, right? In the Neo4j library, and they can dynamically automatically loads the node and edge from the API dependency that I generate from the UChecker, right? The API dependency, I think I told you before, is a data flow and a control flow. And after when we have the database, graph database to represent application, right? We can leverage another method. It's called graph embedding, right? It's called graph embedding, and it can transform the graph or the node to a to a feature vector, and this has already has a tool that's developed by the PyTorch, from the YouTube, from the Facebook, right? It has a already tool for doing that. I have no time to study this completely, but I have some direction, right, for this. So my idea is to find the similarity between the malicious ones and the benign one. Okay, let me demonstrate that. So this is your checker, right, to generate the graph, right? And I use a combine to control the control flow right here, and the data flow is right here. So for the vulnerability, vulnerable samples, we also use the unrestricted file uploaded, right? The vulnerability, right? The API just a call directly without any check in the control flow, right? So this vulnerable code is from the mini CMS from the GitHub. And here is another vulnerable sample. It's a WordPress plugin, right? It's very different from the GitHub. It's another platform, but the vulnerability is the same, right? The move uploaded file directly be called, but without other check the file extension, right? So you can see the picture. You can see the graph about this vulnerable. So it's pretty same, right? You can see that it's pretty same. And here is an invulnerable example. They check a lot of things before call the move uploaded file. So you can see the big difference between the invulnerable example with the vulnerable example, right? So here is the parallel compare for the two vulnerable examples that I generate from here. So you can see that the only difference is here it's used in caps. Oh, sorry, let me enlarge this. They only use in caps, and here they use another function call to get the file name, right? The only difference is here. It's pretty similar. I think if we can use, if I can use study the graph embedding things, I think if these two graphs translate to a vector, it's pretty same, right? We can say it's pretty close than this one, right? So you can see here is a database, data flow, and this branch, a lot of this node is a control flow, right? So I have coded this program, and here is the graph I generate from the use checker, and here's the demo for this one, and we can generate these three graph in the graph database, and I using this query, right? Match the super group. Don't care about the super, that is a prefix, right? So you can see that this is the open flash chat. It's a vulnerable plugin in WordPress, and this is a mini CMS. It's from the GitHub. These two graph is very close, right? And here, this graph, right? Hit this graph. It's called full screen background. It's a vulnerable example that's in the WordPress plugin, right? You can see the lot difference, right? The huge difference between this graph. And that is what I want to show in today's interview. Yeah, that's it. Thank you.